Good afternoon and welcome to our webinar, Desktop Virtualization Steps for Success. My name is Kevin Cook and I'm a Market Development Manager with Terakai Corporation. This is the first webinar in a three-part series to focus on virtual desktop infrastructure, the next generation desktop strategy. I'm very pleased to introduce Matt Boyajian. Matt is an industry leader and virtualization expert with over 13 years experience in designing, architecting, and optimizing desktop implementations. Today, Matt will present on how to move to virtualized desktop infrastructure, which really requires us to think and plan a bit differently. Specifically, part one in this VDI series will focus on assessment, design, and creating a proof of concept architecture. So without further ado, I'd like to welcome Matt.
Good afternoon, ladies and gentlemen. My name is Matt Boyajian. I'm the Solutions Architect, and we're going to be talking about designing steps to successful VDI. So as I mentioned, my name is Matt Boyajian, the Solutions Architect, and this is Steps to Successful VDI. Today we're just going to be talking about assessment, design, and POC architecture. As mentioned earlier, this is going to be a three-step process. This is one of the three presentations that you will need to understand in order to understand the complete A to Z architecture of implementing VDI within your organization. Now, in terms of an overview, what we're going to be talking about today is first, assessing to gauge best fit for VDI clients. Second, we're going to be talking about designing a POC, or a proof of concept environment. Third, we're going to be talking about migrating a physical image to virtual via P2V. And fourth, we're going to be taking a very large look at image design. Now, please note that this particular portion of image design is going to be looking at images from a very high level. In other words, persistent versus non-persistent images, linked clones and how you can evaluate those, etc., etc. We are not going to be talking about specific best practices for specific operating systems like Windows XP, Windows Vista, and Windows 7. Instead, that will be covered during Phase 2. So with that, let's start talking about Step 1, assessment. So in terms of an assessment, you should already know you should not be considered a candidate for VDI if you have high CPU, disk I/O, memory, network I/O, or graphics intensity. Now, the limiting factor isn't that these types of machines cannot be virtualized, that they instead consume a disproportionate amount of resources compared to the rest of the user base. Now, this will offset the amount of users that can be properly run in the environment and dramatically increase the TCO of that specific environment. Therefore, you should assess as many different pockets of users in your organization in order to achieve the highest resolution of VDI activity. Now, that being said, I should issue a bit of a warning. You do not want to second-guess client behavior. If you assume that certain clients should be excluded from VDI because you think they have high CPU, disk I/O, memory, network I/O, or graphics intensity, or underestimating our clients' efforts, work, activities, or needs. So in that specific regard, it's usually best left to an assessment device or an assessment software solution to actually carve out whether a client is a good, a fair, or a poor candidate for VDI. So in terms of assessment hints, first off, the goal of an assessment is not a final VDI design, rather an analysis of the feasibility of a desktop virtualization project, given the combination of a network infrastructure, user applications, and desktop environment. Now, to be successful later, you need to create a comprehensive foundation now. You need a comprehensive assessment findings correlation information from an assessment tool. You need a baseline design, which is even more critical for the validation of the user experience. And then on top of that, you also need application inventory and application utilization. So some clients will ask me, well, if the goal of an assessment is not final VDI design, why do I need an assessment tool? Now, the assessment tool is designed to get you started, and the reason that you need it is because when you're designing a POC environment, you must not have any bottlenecks in the system. Otherwise, it will skew the design, and then the assessment is essentially worthless because you're going to be reporting on bad data. So by designing and architecting based on the assessment tool, eliminating bottlenecks, you can start focusing on the more important aspects of a POC, which is image optimization, architecture, image design, what kind of images you want to run, what kind of user behavior you should be seeing, evaluating baselines, etc., etc. Now, it's important to note that this may seem exorbitantly complex. In some cases, it is. This is necessary to deploy a successful VDI environment. There have been many companies scattered by the wayside that have fallen when they tried to implement VDI without help, without a partner like Terakai, without a successful software piece that can actually monitor this portion. Don't be one of those companies. There's plenty of examples out there. We're not going to talk about those. We're only going to talk about what makes you successful. Step 2 is going to be designing a POC environment. Now, this is assuming that you've completed a full assessment and you've identified the following. 1, the distribution of your users across your environment, whether I have good users, fair users, or poor users for VDI. 2, that we actually were able to utilize both Terakai as well as an architecture tool to design a physical environment to host your virtual POC. So what architecture we need, how many IOPS do we require, how much memory we require, how much CPU do we require, what kind of back-end switching environment do we need. Once we have all those things, now we can talk about designing a POC. So once you have a sampling of users you want to design your POC for, you need to architect the initial environment. Now you need to start small here, as the majority of POC will be spent focused on 3 separate areas. Number 1, designing pools of users to account the different types of users your organization wishes to virtualize. This is also known as tiering. Tier 1 is going to be your heaviest users. Tier 2, slightly heavy / power users. Tier 3, day workers. Now it's important to understand that you don't have to do all these out of the gate. Your organization may just wish to virtualize the day workers now. That's perfectly okay. Just recognize that an ongoing monitoring tool is necessary if we want to expand that to Tier 2 and Tier 1. The next important piece is going to be optimizing the virtual image. Now, a lot of companies overlook this piece. This is by far one of the largest gains that you can make in designing a VDI infrastructure. Why? Because if you can decrease the idle utilization and ongoing utilization per image by 50%, then you can double the amount of clients that you can host per an ESX or a Citrix hypervisor environment, meaning that we can literally double our ROI if we focus on optimizing the image appropriately. Third, we're going to want to architect the pilot environment using data gathered from the POC environment with an assessment tool and a monitoring tool. The reality is, within phase 3 of step 2, you need both. You need to understand what your clients are utilizing. You need to set baseline expectations and need to utilize those metrics to design your next environment. Now, the POC environment is going to be a little bit less overhead than the pilot environment is going to be a little less overhead than your POC environment. Now, why is that? Because the POC environment was designed to eliminate all bottlenecks. Now, when you're in pilot, you're going to be ramping this up, and your management's going to be asking what your ROI and TCO numbers are. So we're going to want to cut down some of that overhead. In order to do that, we have to be more accurate in regards to monitoring, because what we're building is actually going to be very, very fairly representative of what we're going to put into production. Now, the following 4 points of data from an assessment tool will be considered mandatory in designing your POC environment. CPU maximum average per user, IOPS maximum average per user, memory maximum average per user, and network maximum average per user. Now, for all of those of you who are just a little bit hesitant about math, I apologize about the next section. Now, the good news is that you don't have to necessarily learn or understand this to deploy VDI. That's why management tools, monitoring tools, and assessment tools, as well as Terakai, exist. Because that way you don't have to go through all this hard work and all this manual steps. You can literally just say, give me your assessment tool, here's the data that comes out of it, now go and design me an environment, and that's how the process works. But for the sake of education, we're going to be talking about this. So we're then going to multiply each of the numbers being CPU, IOPS, memory, and network, by the amount of users that you want to architect the environment for. For example, if each user uses 10% CPU maximum average, and you want to architect for 50 users, then you would divide 10 from 100 to find your users per core ratio. In other words, the amount of users you're going to get per single core of a CPU. Then divide that from the number of users from total to find the maximum amount of cores that you should have in your host. In this example, 5 is the minimum. IOPS, network, and memory will be similar multiple input values. So If your maximum IOPS across each client is 7 and you have 50 clients, then your storage needs you to be able to deliver at least 350 IOPS to be effective. Note that I say at least, especially during a POC. You're going to want to overbuild this environment slightly. So having something along the lines of 500 IOPS minimum would not necessarily be a bad thing. Again, we're trying to eliminate bottlenecks here. Now, you have to note that this environment is generally considered overkill by most standards, but it's important to give a POC environment plenty of extra bandwidth, as we can't create artificial bottlenecks when we are architecting for future systems. Again, that's going to skew your numbers. Now, we've mentioned monitoring a few times already, so let's talk about monitoring in a POC environment. As your image becomes more and more optimized, your variables used for determining your next stage of your VDI environment will change. As a result, you need a way of monitoring assessment, user experience, and image efficiency, all three at once. And again, Terakai can help you out with solutions like this. There's plenty of those in the market. Decide which one works best for you and utilize that to its full potential. In some cases, you might need to use multiple tools. Now that step 2 is finished, let's talk about step 3. Step 3 is migrating the physical image to virtual, also known as P2V. Now, there are many, many tools available today to help facilitate P2V migrations. VMware's tools are considered the standard, but many third-party developers are creating tools that help accelerate the process. You must remember that a P2V image seldom is kept the same format and footprint when migrating to a VDI environment. So if one of two methods are recommended when moving into the virtual world at first. If you're planning on utilizing existing images to build your virtual images going forward, it's important to develop an efficient, repeatable, and possibly automated method of moving to physical to virtual. I should point out that this first method is a lot more work than it seems, because really the best idea, you're going to find a lot of differences between your physical and virtual images. The differences are really going to be staggering, and we're going to cover those in the second presentation that we have to talk about. Now, we're going to be talking about removing search entities, changing service orders, removing drivers, completely pulling out whole aspects of your original operating system that you're using across your organization right now. Literally a complete redesign. So in that case, designing a process is the bare minimum of things you need to do. The problem with that is that the process tends to be very, very lengthy. So in most cases, it's advisable to either script it or automate it or design a front end to do that. In previous instances when I was responsible for this kind of work, I designed a fully automated front end, meaning that it had automatic WMI detection. It would figure out that we're on a virtual instance. It would automatically reconfigure everything, completely revamp the image on the fly, and then we'd use that as our base image within virtual. That was a tremendous amount of work. This kind of thing literally can take months to develop, which is why usually we recommend stage 2. It is highly recommended that you develop a separate image build process or processes in order to maximize the efficiency of each image. This will allow you the greatest flexibility in determining what you can pare down from the image in order to minimize system idle IOPS, base memory usage, and CPU utilization. Also, don't forget network utilization in there as well, because again, that's something that you're going to have to contend with. Switches are expensive. This is the simpler process to follow. Now, a lot of organizations have spent the last 5 or 10 years trying to decrease the amount of images that they have within the environment. So usually when people read or see or hear this, they say, well, that's counterintuitive. That's exactly the opposite of what Microsoft and everybody else has been telling us over the last few years. The simple fact of the matter is this. VDI is different. You cannot treat VDI as a desktop solution. You cannot treat VDI the same way you treated server virtualization. If you fall into either of those pit holes, you will fail. So look at this with a fresh set of eyes and consider the fact that you're going to have to do one of these. The easier method is to have the separate image. It's also highly advisable to utilize external control mechanisms for systems management wherever possible. So what I mean by that, such examples would be centralized control of antivirus, application updates, application publishing, and domain control. Now, each of these is a little bit different. By antivirus, what I mean by that, if you can go with appliance-based AV, do it. Because instead of having antivirus controls times X amount of clients that you have in your environment, you now have a single appliance based per host. This is going to decrease utilization tremendously, giving you more users per host, giving you a better ROI. Application updates, same thing. If you can utilize a standard mechanism, Great. However, we're going to be talking about non-persistent and non-persistent link clones in a little while. Now, if you can, whenever possible, use non-persistent link clones, because that means your application updates, if they're included with the image, can be as simple as update the image, put it back out there, and if you couple it with a management solution and a streaming solution, you now can update 1,000 clients just by updating their base image. Very simple. Application publishing, again, if you're using standard distribution mechanisms, that works well in a persistent environment. We're going to be talking about what that is in a moment. But non-persistent link clones, not so much. Again, in that particular case, you're going to be looking at a streaming solution, something along the lines of either AppV, SVS, or ThinApp, something along the lines of those mechanisms. Finally, domain control. Most organizations have some form of domain control present within their environment already. Active Directory is a great example. 99% of organizations use it. Utilize it for VDI. Just keep in mind that you cannot and should not maintain and manage your VDI systems in the same bucket as your physical desktops. They will require different processes in almost every conceivable way imaginable. Now with that, we're going to talk about step 4. Now I know we've kind of breezed through the first 3. Step 4 is a bit big. We're going to be talking about a number of complex and semi-complex topics and how these all relate to your basic image design. Now keep in mind, this is, as I mentioned before, high level. We're not going to be talking about specific operating systems. So instead, we're going to cover how applications should be layered onto the operating system and how that can affect overall planning when designing your VDI environment. So I already kind of gave away the farm here in speaking about some of the examples earlier in the presentation with persistent and non-persistent images and link clones and application streaming. So if anyone didn't understand what I was talking about with any one of those terms, we're going to be talking about that now. So let's talk about image design for persistent images first. Now this is the simplest form of VDI. A lot of organizations that have looked at VDI over the last 3-4 years, especially those organizations that started way, way early, about 3-4 years ago, this is all we had. All we had was persistent images. So persistent images are defined as images that map one specific user to one specific machine. This is the most cost-prohibitive form of VDI. It's been shown that a persistent image can cost more per user than a traditional desktop. A little bit of an aside to add in there. More often than not, laptops are more expensive. Now, I suggest that you run your own individual analysis to see what machines cost you per year, per user, etc. From my personal evaluations and my personal research, I find VDI to fall right smack in the middle between desktops and laptops when it comes to persistent, thick images. Some of the other ones we're talking about, not so much, and we'll talk about that in a moment. In some cases, however, even though this is the most expensive form of VDI, the gains outweigh the costs, such as when a database or a network-intensive remote application must be used in the field, or a high-speed connection is not present. Now, you see those 3 little asterisks down at the bottom? This is a pretty big deal. Persistent images should only be used in an environment where it is not possible to use a non-persistent image. So what is a non-persistent image? Let's talk about it. A lot of words here. I promise we'll get through it together. Everything will be fine. So non-persistent images are defined as images that do not retain a one-to-one relationship between user and machine. User can log into a system and may receive a different machine each time. This can have a tremendous impact on total system design costs, as the amount of non-persistent systems being served by the host only has to be as great as the maximum amount of users that are logged into VDI at any one given time. This greatly reduces the operating system licensing costs, as well as the application licensing costs and hardware costs. So let's talk about examples for a second. So if we have a pool of 100 users, but only 50 of those users are logged in at any one given time, then your VDI environment only has to be designed to accommodate 50 virtual systems. It should be noted that unless your environment prevents you from running and utilizing non-persistent images, then this is the type of environment that you should be employing. Now, why would an environment prevent us from running a non-persistent image? We're going to talk about that in a moment, but there are certain pitfalls with it. So let's talk about one of those right now. The downside to a non-persistent image is the fact that because a user may log into any number of different hosted virtual machines at any time, The specific user data read or written to the virtual machine is only temporary. Now, this is also known as a destructive pool. So anybody that's actually paying attention with all the geek manuals that get passed around, this is an example of what a destructive pool does. In order to combat against this, two technologies must be used. The first is a profile redirection service. This type of service allows any user profile data, such as desktop settings, application data, or any pertinent data that is cataloged in the HKey current user. Now, a lot of folks might be saying, well, we have that already. We have Microsoft roaming user profiles. And again, for a free tool, and I stress free tool, Microsoft roaming user profiles is an okay tool. However, it should be noted that the goal of VDI is not just to deliver something that is cheaper for the user. We have to be providing a better experience than what they currently have. Why? Why do we have to do that? Why, as IT professionals, do we have to deliver something better? Because the reality is that for many, many years, we've been presenting systems as veritable trophies, if you will. A user doesn't have a laptop on their desk. A user doesn't have a desktop on their desk. If a user has a desktop, that's your standard run-of-the-mill that's as good as a paperclip. You might as well have given them nothing. But if you give a user a laptop, that's a status symbol. You give them a thin and light laptop, that's a trophy. So when you go and take away that trophy and you give them something that's faster, that's cheaper, that's easier to manage, it had better give them a better experience than what they had with that laptop. Otherwise, they are going to call up the help desk and complain every single day until they get that laptop back. It's unfortunately one of the psychological aspects that come along with VDI. How do you combat against this? How do you actually prevent your users from doing that? Information. You need to arm yourself with the ability to say, well, Mr. Johnson, when you called up today, I can see exactly how long it took you to log into your VDI system. I know how long it took you to launch Microsoft Office. I know how long it took you to launch your email client. When I go and compare that data to your old slow laptop that I could not pry out of your cold fingers, your old slow laptop was much slower. Without that information, you are literally going to be chasing your tail ad infinitum. So again, this is why not only assessment data is imperative, but also monitoring data, and you have to have a way of leveraging those two and figuring out what your differences are. So when a user calls up, you know when you really have a problem versus someone who's just trying to get that old laptop back. And again, other folks might be saying as another point, well, if I'm not using Microsoft roaming user profiles, what should I be using? Well, there's a number of tools on the market. Ask Terakai. That's why they're here. And also, if you start using Microsoft roaming user profiles within an experience like this, and it is worse than their laptop, no one's going to want to use it. This project, VDI, has the ability to put IT back in the forefront of the company. If you do it properly, this will help immensely. If you fail, it's a black eye for your CIO, and no one wants that. Okay. The second thing that we need to talk about is a technology called an application streaming service. Now, again, we spoke about that very, very briefly before. We talked about AppV, we talked about ThinApp, we talked about SVS. Now, how these work is application streaming services allow any prepackaged virtual application to be streamed to the desktop. The further benefits of this will be discussed in streamed applications portion of the presentation. We're going to be talking about that in a minute. It's important to remember that the best practice for a non-persistent image is to not let users install applications to the system, as the next user that logs into the system will now have access to an application that they may not be licensed for unless you're using a destructive pool. Using destructive, everybody gets wiped away after the fact, and if they install the application, you might as well have just thrown it away because you're not going to get it back unless it's streamed. This can also lead to a cluttering of systems, since installing a large amount of applications on pooled machines with no way to track or manage them can clog a VDI system. Now, obviously, if you're using destructive pools, this isn't an issue. But you can't use destructive pools without both a profile management service and a software streaming service. So it's a bit of a 50-50. Now, let's talk about non-persistent link clones. Now, we're not supposed to be talking about specific vendors here. Unfortunately, you can't talk about specific vendors and not mention link clones. So link clones is actually a VMware technology. So it's possible to reduce storage costs dramatically within a VMware environment, a VDI environment, by deploying non-persistent image known as link clone. Linked clone images reference a standard master image that is stored within the host. This dramatically increases the operating system speed while reducing storage requirements. Now, how does this work in plain English? Essentially, what we're doing is we're taking a standard image. Before, each of your users might have had a 20 gig hard drive, and we're going to take that 20 gig hard drive and chop it down to like 15 gigs. And then for every ESX host you have in your environment, they're going to cache or capture that image. It's actually stored within your storage controller, but each server has their own. Now with vSphere 5, no one needs to have cache per host, but whatever. We're not going to talk about that right now. We're complicating things enough already. So what happens then is that each user that logs into this system is now only going to be storing differentials to the image. So what does that mean, differentials? That means that anything that's different than the standard image is essentially going to be captured. So instead of each user getting 20 gigabytes worth of space per image, you now only have to store around 500 megabytes per user, which is going to significantly decrease your storage costs. In some cases, you can see up to an 80% decrease in storage costs across VDI. This alone is going to allow VDI to drop below the cost of a traditional desktop. One moment, please. The control panel is nagging me that my microphone level is loud, so I'll try to move that to help you guys out. So if we drop the storage costs, which are the second most expensive part of VDI, first being licensing costs, we have the ability to drop the cost of VDI below that of a standard desktop. Not a laptop, but a desktop. So not only are we providing an experience that could theoretically be better than your current machine, we're also going to make sure that it's cheaper than your current desktop. So management likes it, the users like it, everybody gets a win-win. The problem is, again, you have to do this in conjunction with the profile management service as well as the streaming application service. All right. Now the benefits. Let's talk about what's good about doing this kind of thing. The amount of data that is required to be stored by the storage controller is reduced dramatically. The amount of IOPS required of the storage controller is also decreased dramatically. So not only do you need less spinning spindles, less hard drives within your storage controller, you need fewer IOPS. You don't need as much storage horsepower to actually deliver a non-persistent link clone image instead. Master image is the only image that is utilized for this operation. Performing service packs, security updates, or large-scale integrated applications have to be completed only on the master image. This means that instead of installing, let's talk about Windows 7 Service Pack 2, whenever that comes out, instead of doing something like that, we can just pull the image, apply the service pack to that, and upload it back to the ESX servers, and we're done. So instead of installing a service pack on 1,000 virtual machines, huge amount of resources, we simply update the image. So again, this technology has a number of benefits that's going to trickle down within other implementations of your environment. And this is precisely why you have to look at VDI as being a completely different technology than the way you manage desktops. It's not to say you can't manage your VDI the way you would desktops, but it's not beneficial to you when you have technologies like this at your disposal. Now, once the image is updated, it is automatically served out to all the users utilizing that image. Any data that the user needs to read or write from the master image is not contained within the master cache, is written to the storage system as a delta. Now, the negative approach to this is the fact when a master image is updated, all the deltas that were written to the specific user since the last master image was published become void. This net effect is the same as any other non-persistent image. User-specific data and application data must be handled by a profile redirection service. And I know I keep harping on this, but again, it's very, very important. Applications must be streamed in order for a user to utilize the programs that they need to perform their day-to-day jobs. Applications must be installed directly to the clone as they will be available to users other than log into the system until it's recomposed. Now, with that, let's talk about streamed applications in a little bit more detail. We've covered some high level. So again, this is one of the two major components that we need to actually make a non-persistent link clone VDI image work. So streamed applications combined with a profile redirection service are the pinnacle of reducing costs within a VDI environment. Utilizing your streamed applications, your non-persistent link clones can be deployed. This is the holy grail of VDI. You can dramatically increase the performance for the virtual desktop, but the amount of resources by consumed each user will drop exponentially. You're literally getting the best of both worlds here. This method allows you to design two appropriate storage pools, one for your VDI systems and one for your applications. Now, a lot of folks say, Matt, why would I want to do that? Why can't I just stick everybody in my nice big box refrigerator storage solution and have everybody run and have everybody have a happy day? The answer is QoS, quality of service. Now, the issue is if you have a methodology of guaranteeing that each and every VDI user is going to get a certain amount of IOPS from your storage controller, then you don't need to do this. The problem is that most controllers cannot give you that level of QoS. So in that case, what you have to do is use your architecture, your monitoring, and your assessment tools to build your specific architecture for both operating systems and applications. That way, you can guarantee the performance of both, and as a side effect, smaller systems are cheaper. So if I only have to design 2 small storage devices, one for OSs and one for software, that's going to be cheaper than that big box refrigerator that needs to house both. And also, if I have a problem, it's going to be easier to fix. Because again, those small boxes with more trays that can be upgraded are a lot easier to upgrade or modularize than that big refrigerator that only has a couple of trays left in it because I decided to stuff everything inside. Now, maintaining the performance of both VDI systems and applications is much easier when these systems are separated. This is because the VDI environment becomes inherently less complicated. All we care about is images. That's all we're doing is images and deltas. If the only traffic from your host to your VDI pool storage is the operating system traffic, then the only traffic that must be investigated in the event of a performance problem is that traffic. Very simple, very easy. VDI is complicated enough, you don't need to make it more so. Consequently, in the event that a streamed application is exhibiting performance problems, then the virtualized and physical machines accessing the application will both succumb to performance problems. So in other words, you're going to know exactly where your issues lay. It's within specific spindles, specific applications, specific servers, and if they're modularized, they're easier to identify and easier to fix. Isolating the streamed applications to a separate storage array allows it to be investigated independently. So you can break this up as much as you want. If you want each application to have its own, LUN, hard drive, storage controller, whatever you want, you can split this up as you need to. And it just makes it easier to monitor, easier to identify, etc. Now, this seems a little bit counterintuitive compared to most of the things that we've heard for the last 10 years, which is consolidate your storage. But you got to remember, VDI is a different animal. It's not like server virtualization. Users hold their computers near and dear to their hearts. When they don't perform well, they call the help desk. When they call the help desk, that costs you money. That's what you're trying to avoid. Now, utilizing an environment of pure streaming, applications in a link clone allows for a near seamless transition to another OS. Now, this is huge. Because think about how much work that you've put into moving from Windows 2000 to Windows XP. And when Vista came out, it was just as big of a deal. No one wanted to do it because it was so radically different. Well, now we kind of have to move to Windows 7. Most organizations are doing it now. And this is a tremendous amount of cost that inhibits every single time we do this. Why are we doing things this way? If we leverage a non-persistent link clone environment, and if we package our applications and our programs and our profiles properly, we can move between operating systems simply by logging into a new one. Now, for example, a user standardized on the Windows XP machine using a profile redirection solution and 100% streamed applications, the migration to Windows 7 or Windows Vista is so much easier. Here's the process of how we go about doing this. First, each streamed application would be tested against the new OS. If it performs as expected, you're done. You don't need to do anything else. In the event that it doesn't, then the streamed application becomes remediated or fixed. In many cases, a future state remediated application will be backward compatible with the previous OS. If this is the case, then the application is simply rolled into existing production. If this is not the case, then a separate package is created that becomes deployed once the user moves to the new environment. Once all the streamed applications have been tested and remediated, the master image can be moved from the old OS to the new one. Now, obviously, you're going to have some testing within this methodology. Some of your users are going to be IT folks that want to try out the latest and greatest operating system. That's okay, because you can use this, and when you're in this environment, you can move back and forth without fear of losing anything. So this also means you can test new OSs, and if you don't like it, if you have a problem, you don't stop working. You just go back to your old OS, you log in, and you keep chugging away doing whatever you do, and that's fine. Now, all user data, applications, and profile-specific settings migrate to the new system, which allows for seamless transitions to new platforms. Now, how long would it take in the event that I've already remediated all my streamed applications to move from one OS to another? Before we talk about that, how long does it take today? It takes you roughly 1 business day. because you got to back up all your stuff. If you have a laptop, you may have been storing it locally. We all do it. It's got to get backed up to a server, to a local hard drive or something. The machine's got to get wiped out, re-imaged. All your data comes back over, and then we have to install all your applications. So this takes one business day. How long does this process take? If I've got my applications remediated, if I know my process, to move from one OS to another? About a minute. And that's being conservative. I've seen it happen in much less time than that with certain infrastructure places in place. So just think about the amount of time that you're saving per user. One business day per user every time you get a new operating system or every time somebody has to get re-imaged. What would your organization pay to reclaim all that lost time? And what if it was cheaper than the things that you're doing today? These are the kind of benefits you're going to get from this kind of infrastructure. Now, this becomes especially important in the future as Microsoft has stated that new platforms will be more frequent with a shift away from revolutionary changes to evolutionary. Windows 8, you could probably look at Service Pack 3 for Windows 7. Just like Windows 7, a lot of people say was Service Pack for Vista. They're not going to be doing huge changes within an OS anymore. It's little incremental updates to make sure that they're on a repeatable schedule. What is that repeatable schedule? 3 to 5 years, which means that every single 3 to 5 years, we're going to have to go through this process again. Wouldn't it be easier if the transition were easier? And that's one of the many benefits we can get out of this kind of architecture. Now, there's much less text on this page, so you're going to hear me speak less. I know a lot of you are very heartbroken about that. Now, some applications have compatibility problems with the wide range of streaming services that are available. I know I've been talking about all this stuff as if it's just great. You can put it out there tomorrow, but lo and behold, there's a couple technical problems that exist. Needless to say, there are ways to get around these problems in the multiple variations that we've talked about today. In the event that this occurs with a particular application that your organization must have within a VDI environment, and there are 3 things that you can help deploy it. Number 1, put the app in your image. Just put it in there. 2, integrate the application within a separate image and manage that image within a separate system pool. And number 3, persistent image, that thing that's really expensive, really cost prohibitive, et cetera, et cetera. So we're going to be talking about why you can and can't do that now. So, integrate the application within your image. For this example, we're going to assume that your organization only wishes to deploy one single image, which that's nice, it's great, it'd be great if it happens all the time, but it doesn't. This solution is applicable for both standard and non-persistent images as well as non-persistent link clones. However, this does not come out without a cost. Application licensing plays a huge part in whether or not this method can be used. For some applications, licensing is based off how many machines the application is installed on. In the VDI pool that you're deploying to, if the amount of licenses that you own is less than the amount of machines in the pool, then the solution's fine. Everything will work out great. Unfortunately, moving an application into the image will cause application performance troubleshooting to be more complicated, but that's a small price to pay for one application that you can employ for your entire infrastructure if you need to. As long as it's not the norm, as long as it's not your standard, you're still not going to lose any QoS just based on 1 or 2 applications. Now, in some circumstances, application licensing can apply to the amount of users actually exposed to the application. If this is true to your application, then the total amount of users that you have access to your VDI pool must then less than or equal to the amount of licenses you own. What does that mean in plain English? If I have 500 users and I have 500 copies of Office, then I'm fine. If I have 500 users but only 300 copies of Office, then I'm going to need to segregate that into a pooled image because not everyone can access it at the same time. Otherwise, someone's going to come knocking at my door asking for a lot more money, and we don't want that. Another option, integrate within a separate image. Integrate the application within a separate image and manage that image within a separate system pool to meet the needs of whatever licensing method is employed. So realize that the complexity of managing multiple images increases directly with the number of images that you employ. If you've got 3 images now and you're adding 4 more with VDI, that's a lot of work for your engineers. But do the gains outweigh the costs? Yes, significantly. You also must consider connection brokers. Some don't support any kind of pool segregation. Some do. Others support pool segregation but can be difficult to manage. Integrating the application into the image can also increase troubleshooting complexity when dealing with the application and image performance issues. But again, we briefly talked about this before. It's not a complicated thing. Now, we're going to talk about the worst case, persistent images, that black sheep that we don't like to talk about. Now, in very rare cases, it's possible that you will have an incompatibility issue with both the profile management service as well as the application streaming service. I have never personally seen this before. I've heard of it. I've read of it, but I've never actually seen it. But again, in the event that it happens to you, you've got a really bad application, just does not work in any solution, you can always deploy a pool of persistent images, a very small pool. The cost is high, but you can still do VDI. And even though everybody else's costs are low, eventually that'll roll together. So, only solution available to your host virtual application within VDI is that of a non-persistent image. Cons. Uses a considerable amount of storage resources. It's big. Requires that a single user be mapped to a single machine. It's heavy. It will have to be managed almost identically to a physical desktop. So all those wonderful things I talked about before, you're not going to get anymore. I'm sorry. Operating system migration will become inherently more complex, and many of the gains that can be realized with VDI will fall away. Licensing becomes more expensive, as a single license will now have to be purchased for each user. This also applies for the operating system licenses for users in the virtual environment, which are significantly more expensive than those in this physical space. Why is that? Talk to Microsoft. Now, this can be mitigated by pulling non-persistent machines, but again, this is not possible in this specific scenario. This does not mean that persistent and non-persistent machines cannot be managed as two separate pools, but it can make managing your VDI environment overly complicated. So again, this is the worst case scenario, and even that is not terrible. Keep in mind that 99.99% of the time you are never going to have to deal with this as long as you work within your restraints and follow these steps properly. Work with Terakai, get a monitoring solution, get an assessment solution, follow the guide. You'll be fine. And ladies and gentlemen, that's pretty much it for the presentation, or at least the first third of it. We're going to be talking about the second part of this presentation relatively shortly. I hope that you all found this very, very informative, and tell your friends, and hopefully I can see you at the next presentation as well. Thank you so much for your time.
Matt, thank you so much. So let's jump right in here to the question and answer. Our first question here is from Brett, and Brett wants to know, how do I get started? Measuring RAM, measuring CPU, network throughput, etc. seems like an exercise in futility.
A lot of folks look at that and they kind of see the same thing. They're like, well, you know, I have perfmon. Why can't I just use perfmon? Or, you know, this is a huge amount of data to go and capture. How can I get started with this? This seems almost impossible, let alone daunting. Well, let's talk about perfmon first. Perfmon, almost every single system administrator has used it at one point in their lives. It's a great tool for some things. It's great at pulling out metrics of the operating system that you may or may not have known that you had. So that's wonderful, but what is perfmon bad at? The answer is everything else. Consolidating that information, putting it in a database, getting reports out of it, inspectors out of it, drawing conclusions from it, deep dive analysis. You can't do these things without a proper tool. So to answer your question, the first thing you should be doing is talking to Terakai, because there's a number of tools that are out there that can help you out with this situation, and they've had experience with just about all of them. So let the professionals do the work for you. And again, I apologize for just laying all this in Terakai, but this is what we pay these companies for, to make our lives easier. So bring Terakai in, say, I have this problem, go and solve it, and let them do the heavy lifting, because why should you have to reinvent the wheel? Why should you have to do all the research? Why should you have to figure out what solution is right for you when they've done it 100, 200, 300,000 times over? And I hope that answers your question, sir.
Matt, here's a follow-on question. This one from Graham. How long should I run the assessment?
That's an excellent question. The short answer is as long as possible, but that's not really realistic, because I don't expect that users are going to run an assessment for a year. You need this information now. The slightly more complicated answer is it depends on your specific institution. Now, if we're talking about standard business, we make widgets, that kind of thing, then it should be run towards the end of your fiscal quarter. Not fiscal year, fiscal quarter. Why? Because that's when crunch time is. And what I'd ideally like to get is at least a 30-day assessment of those users as they're really cranking away on those machines. Now, if we're talking about standard scholastic enterprise, K through 12 is a lot different than collegiate level. K through 12, the best time to run it is from April to May. Collegiate level, the best time to run it is either from November, early November to early December, or mid-April to mid-May. Why? Because that's finals time. That's the data that you want to consume. Financial institutions, again, the end of your fiscal quarter is also a good time to have. Other organizations, it usually falls in that 30-day range. And the big thing that we want to try to avoid is any large-scale vacation times, large-scale gaps in productivity or user utilization. But as long as we can get a minimum at that, we should be pretty good. And I hope that answers your question.
Excellent, Matt. Thank you. One other question here. How do I determine what portion or percentage of my users should be assessed?
Okay, that's an excellent question. The absolute Cadillac is 100%. Now, again, I mentioned earlier that trying to second-guess your user base in terms of an assessment is not a good idea because, unfortunately, as IT, we either over or underestimate. It's just, unfortunately, the nature of the beast. So that being said, I'd love to get 100% distribution, but again, I'm a realist. I represent that not everyone has the time or the resources to get that kind of utilization out of all their business units. It's a lot of work. So what's good? 50% is good. 50% for all of the departments that you're looking to virtualize is decent. The absolute bare minimum that I will not go below is 30%. But again, 100 is great, 50 is okay, 30 is, well, we can get by with 30.
Excellent, Matt. Excellent. I'd like to thank you all again for your participation and insightful questions. I hope that this webinar met with your expectations. If desktop virtualization is in your IT roadmap, as Matt said, please join us for Part 2 and Part 3 of this series. We're going to put the dates and the topics up on your screen right now. Terakai Corporation will be hosting these regularly, and we'd love your input and thoughts on topics. Again, thank you again so much, and good afternoon.